you have two elements that repeat, and the smallest possible rearrangement wins. Fix all but the two middle characters as their sorted smallest form, and put the two smallest value distinct letters in the very center to keep it a palindrome. In short, given a string that's already a palindrome, find the alphabetically smallest way to rearrange its letters so the result is still a palindrome. Intermediate level, you never touch the second half of this string. Get the first half right, and up to 100,000 characters snap into place behind it automatically. By the end of this, you'll spot this shortcut in seconds on any palindrome problem. Think of autocorrect finding the closest valid word to what you typed. This is that same idea, just for palindromes. Scientists use this exact shortcut to repair errors in DNA sequences. One small trick, two very different words. We get a string that's already a palindrome, like babab, and we need to rearrange its letters into the smallest possible palindrome. Same letters, same palindrome property, just the tiniest lexicographic order. The answer here turns out to be ABBA. A hash map here is like a tally sheet. One glance tells you how many of each letter you've got. Sort those letters alphabetically, then all we do is glue strings together. That's genuinely the whole toolbox. The obvious idea, generate every permutation of the string, keep the ones that are palindromes, and pick the smallest. That works fine for Baba with 5 letters. But this string can run to 100,000 characters, and permutations explode into more possibilities than atoms in the universe. Here's the trick. A palindrome is just a left half, mirrored, so the right half is forced to copy it backwards. I call this the half and mirror trick. Count the letters, split each count in 2, sort them. Done. Clean. First, we tally every letter with the hash map. This tells us instantly how many A's, B's, and so on we have. Since the input is already a palindrome, every count is even except maybe 1, which becomes our middle letter. We warp the letters in alphabetical order because the smallest half means smallest letters first. Whichever letter has an odd count becomes the middle. I used to forget to pull that one out separately, and it broke my palindrome check. Every other letter just gets split exactly in half. Now we just glue it together, the smallest half, the middle letter if there is one, then that same half reversed. In short, build the left side once and the mirror writes the right side for you. Pause the video. What's the smallest palindrome you can build from tacocat? Count the letters and try it before I reveal the answer. Counts come out to T2, A2, C2, O1, so O is the odd one out and sits in the middle. Half is at, so the full answer is ACTOTCA. If you got that, you officially got the pattern. For tacocat, brute force would generate all 5040 orderings, filter for the palindromes, and pick the smallest, totally doable by hand. But this exact approach is what falls apart the moment strings get long, which is exactly what we compare next. Brute force costs big O of n factorial, because you're generating every ordering of n letters. The half and mirror trick costs big O of n, 1 pass to count and 1 pass to build. Past the handful of letters, factorial time isn't just slower, it's impossible to finish. A single character like Z has an empty half and the whole string as the middle, so the loop just does nothing extra. If every letter is identical, like the half is just and mirrors itself perfectly. If the input is already the smallest palindrome, we still rebuild it the same way, so no special casing is needed anywhere. Remember that permutation explosion from the start? Splitting each letter's count in half and mirroring it is exactly what dodges it. Count, split, sort, mirror, that's the whole solution. New daily drops tomorrow, same time, where this same mirroring trick cracks a much harder rearrangement problem. This concept is layered. The subscribe button has one layer, click it.